right, good morning, guys. So today we are going to start lesson 9.6. We're going to be talking about using inverse trig ratios and talking about what does it mean to solve a right triangle. So we're going to be working on pages 46 through 48 in your notes today. So go ahead and grab your note packets out. I have the first problem already set up, ready to go. Okay, so the first problem says determine which of the two acute angles has a cosine of 0.5. Okay, so you can see you have a right triangle here, triangle ABC, side lengths of 1, 2, and root 3. If we're asked to determine which acute angle, either angle B or angle, put an arc on angle A, these are my two acute angles. If I'm trying to determine which of those two acute angles has a cosine ratio of 0.5, I want to actually look at the cosine ratios. Okay, so I'm going to get started by writing SOHCAHTOA. So since I'm focusing on the cosine ratio, that means I need to look at the adjacent hypotenuse side of this right triangle. All right, so let's start with angle A. Okay, so I have cosine of angle A. And the cosine ratio is the adjacent over the hypotenuse side. So let's go to angle A and label our triangle. This side is your opposite side because it's across from angle A. This side is next to, this is your adjacent side. The hypotenuse is always across from the right angle. That never changes. Okay, so cosine is adjacent over hypotenuse, so that would be root 3 over 2. All right. Now I need to look at the cosine of angle B. Okay, so here's angle B, but watch. My opposite side now is this one, root 3, and my adjacent is the 1. So I need to erase opposite and adjacent. Since I'm focusing on this acute angle, across opposite is the root 3, adjacent is the 1. Hypotenuse doesn't change. So now I have cosine of angle B is equal to adjacent over hypotenuse, 1 over 2. And there are your two cosine ratios. So again, the directions say, determine which of the two acute angles, angle A or angle B, has a cosine of 0.5. So now you can see the cosine of angle A is root 3 over 2. The cosine of angle B is 1/2. So which one is 0.5? It would be this one here. So your answer would be angle B has a cosine ratio of 0.5. All right, so there is problem 1. Give me a minute to erase my board and we'll get set up for the next part. All right. Okay, so now we're going to start talking about inverse trig ratios. Okay, and if you follow along in your notes with me, right under that first example. All right, so it says let angle A be an acute angle. The inverse tangent of tan A equals x is tan, and then that little -1, that exponent -1, that's the inverse tan of x equals the measure of angle A. All right, so what does that all mean? Okay, the notation there might be a little overwhelming and confusing, but what they're telling you is that you can use the inverse tan to solve for the angle measure. So far we've been using sine, cosine, and tangent to solve for a missing side of the triangle. Well, if I'm trying to find the missing angle of a right triangle, we can use the inverse functions, okay? So the first example, it says, let angle A, B, and C be acute angles. Use a calculator to approximate the measure of angle A, B, and C to nearest 10. Okay, so we're going to write these out because I want to show you algebraically how to isolate the variable because that's always very important. All right, so for problem A, I have tan A equals 0.75. Okay, so algebraically what we're trying to do is we're trying to find the measure of angle A. I want to know what is that angle measurement. So in order to get A by itself, in order to isolate the variable, solve for angle A, what we're going to do is take the inverse tan of both sides of the equation. So writing it out, what it looks like is this. The inverse tan of this side of the equation, tan A. And then since I'm taking the inverse tan on that side, I also have to take it of the other side, because whatever I do to one side of the equation, I must do to the other. So the inverse tan of 0.75. Now, inverse functions, addition, subtraction, multiplication, division, they undo each other. So inverse tan and tan undo each other. So you're left with A is equal to the inverse tan of 0.75. And at this point now, it's a calculator problem. All right, which I forgot my calculator in the other room, so hold on one second. Okay, so it's important to be in degree mode, as we've talked about. So on the top of your calculator, make sure it says degree. If you're not sure if it's in degree mode, hit that mode button and make sure you're in degree mode. And then above tan, see above the tan button, there's in blue tan, and then that exponent -1, that's the inverse tan. So to get to any of the blue functions, blue features, I push the blue second button. So second tan, that's going to be inverse tan, and then I type in the 0.75. And you push enter. And you get, I can't read backwards, sorry, 36.86989765. All right, so the directions here say to round, what does it say to? Round to nearest 10th of degree, so it's 1 decimal place. What color was I using? All right, so that's 1 decimal place, so that means the measurement of angle A is approximately 36.9 degrees. Okay. All right, so let me erase that. We'll do the next problem. So we'll move a little faster through the next two. So the next problem says sine B is equal to 0.87. I'll write the last one up as well. Cosine C is equal to 0.15. All right, so when you're trying to solve for the measure of the angle, you're going to take the inverse of both sides. So in this case, the inverse sine. So inverse sine of sine B is equal to the inverse sine of 0.87. Sine and inverse sine undo each other, so B is equal to the inverse sine of 0.87. Once I have my variable isolated, I'm going to pick up my calculator. I'm going to type in inverse sine of 0.87. Enter. And you're going to get 60.5 approximately. So the measure of angle B is approximately 60.5 degrees. Okay. So if you want to pause and try angle C on your own and then see if you do it correct before watching, you can. That's a good idea. All right, I'm going to keep on going. I'm going to take the inverse cosine of both sides. So I'm going to have the inverse cosine of cosine C is equal to the inverse cosine of 0.15. So I'm going to have C is equal to the inverse cosine of 0.15. Pick up my calculator. Inverse cosine of 0.15. And you get 81.4 approximately. So the measure of angle C is 81.4 degrees. All right, guys, we are going to keep on moving along. So turn to the next page. Let me get set up. All right. So on the next page, it says, solving a right triangle. To solve a right triangle means to find all the unknown side lengths and angle measures. You can solve a right triangle when you know either of the following: 2 side lengths, 1 side length, and the measure of an acute angle. All right, so to solve a right triangle, as I just read, means to find all the missing pieces, all the missing angle measurements, all the missing side lengths. Keep in mind, we have multiple methods. We definitely can use trigonometry, and we will use trigonometry, but you also know Pythagorean theorem. You also know special right triangles, 45, 45, 90, 30, 60, 90. So keep those all in mind as you're looking at these problems, okay? So the first example says solve a right triangle. And that's the other important thing. When you read the directions of a problem, if it says solve the right triangle, you need to understand what that's asking you to do. Again, solving a right triangle means find all the missing pieces, okay? So solve the right triangle, round decimal answers to the nearest tenth, so 1 decimal place. Okay, so let me draw up the diagram, and then we'll get started. We have our right triangle, A, B, C, and we have side lengths 3, 2, and C. Oh, side note, let me also explain something else. When we label our right triangle, okay, most of the times, not always, but most of the times, we have angles A, B, and C. And think about Pythagorean theorem. When we set up Pythagorean theorem, we always say a squared plus b squared equals c squared. C meaning the hypotenuse. So if this angle is angle C, across from it is little c. Angle A across from angle A is little a, and angle B across from angle B is little b. So most of the times with our right triangles, we're going to be labeling them A, B, and C. C will always be the right angle because across from the right angle is side C. The other two, it doesn't matter. I could have put B there and A there, and if I had put the A down there across from angle A, this side would have been little a. So the angle letters and the side across from them always agree, match up, if that kind of makes sense. Okay, so that was a little side note, something that is important to know. Okay, and notice here we have angle C across from it is side C. All right, so if you know 2 of the 3 sides of a right triangle, what method can you use to find this side here? Hopefully we're all thinking Pythagorean theorem. We can't use special right triangle information because I don't know if these are 30-60 or 45-45-90. I know it's not 45-45-90 because it's not isosceles, right? These two would have to be the same. All right. I can't use trig yet because I don't know one of the angle measures. I mean, I could find this angle measure and then go from there, but it probably makes sense to use Pythagorean theorem to solve for this side here. Okay, so I'm going to say a squared plus b squared equals c squared. A and b are these sides here. So I'm going to have 3 squared plus 2 squared equals c squared. 9 plus 4 equals c squared. 13 equals c squared. C equals the square root of 13. Okay, and I might want to come over here because that might help me with other problems. Now, typically we want to try to not use approximated answers in other parts of the problem. So I'm pointing that out because you wouldn't want to change this into a decimal approximation and then use that decimal approximation to solve for other pieces of the triangle. Try to avoid doing that. Okay, now I need to solve for angle B and angle A. So we are going to use trig, SOHCAHTOA. TOA. Okay, so let's look at one of the angles at a time. If I look at angle B, across from angle B, this is my opposite side, this is my adjacent side, and this is my hypotenuse side. So I have to decide what trig ratio do I want to use to solve for angle B. Okay, I can use sine, cosine, or tangent. Since I prefer not to use radicals in my calculations, I want to use the opposite and the adjacent, the 3 and the 2. So opposite and adjacent are tan, so I'm going to set up tan of angle B is equal to opposite over adjacent. Okay, it wouldn't have been wrong to use root 13, but it just might make the calculations more challenging. Now, we just saw in the last set of examples, how do I solve for angle B? I use the inverse tan of both sides. So inverse tan of tan B is equal to the inverse tan of 2 over 3. So just keep in mind, whenever you're trying to solve for an angle, that's when you're using the inverse tan. They're going to cancel. So the measurement of angle B is going to equal the inverse tan of 2 over 3. So now I need my calculator. All right, so the inverse tan, there's my tan, and then I'm going to get my fraction, alpha y equals 2 over 3 enter. You get 33.7 because we're asked around to the nearest tenth. There's 33.7. So the measurement of angle B is approximately 33.7. Okay. Now, we do know that the three angles of a triangle add up to 180, so we could use that fact to solve for angle A, but I'm going to set up another trig ratio just because that is what we're learning, so it's good practice. Okay, and this side right here, that's what I'm going to do. So now looking at angle A, remember to change your labels on your triangle. If I'm focusing on angle A, the hypotenuse isn't going to change, but this is going to be my opposite side, and this is going to be the adjacent side. So opposite, adjacent. So if I want opposite and adjacent, again, it's going to be tan. So tan of angle A is equal to opposite over adjacent, 3 over 2. So I solved this one the same way I did that. Take the inverse tan of both sides. I'm going to kind of take a little shortcut just because of the space. The measurement of angle A is going to equal the inverse tan of 3 over 2. So take your calculator and type in inverse tan of 3 over 2. Where am I? There we go. And then push enter, and you're going to get 56.3. The measurement of angle A is approximately 56.3 degrees. Okay, and you're done. You know all the pieces of that right triangle. Okay, so you solved the right triangle. All right, let's move on. All right. So we have another one that says solve the right triangle, round decimal answers to the nearest tenth. Okay, so let me draw up this diagram. Give my board a minute to dry. It's hard to write on it when it's wet. All right, hopefully that's good. Okay, so my right triangle for this one looks like this. And the pieces that are given, first off, it's triangle. They use different letters this time. That's side G, or angle G, excuse me, angle H, and angle J, okay? So across from angle H is little h. Across from G is little g, and then across from J would be little j, but that's actually given as 13, so we can label that. And then this angle is given as 25 degrees. Okay, so that was all the given information. We want to solve, so that means we want to solve for angle G, side G, and side H. Okay, so instead of setting up a trig ratio to solve for angle G, if I know that these are 90 and 90 and 25, I'm going to add them, subtract from 180 to get the measurement of angle G. Okay, so we are going to be using old pieces of information like that. All right, so I don't think I did that on here. We have the measurement of angle G is going to equal 180 minus 90 minus 25. So the measurement of angle G, 180 minus 90 is 90. 90 minus 25 is